Hello, I'm Simone Manzato from Siemens PLM, and what we are doing today is we will show how to perform modal testing and analysis by using both hammer impact testing and MIMO FRF with shaker on a component of an housing of an automotive gearbox. So we just finished now instrumenting the component that we want to test. We place several triax accelerometer on both planes of the gearbox in a way that we are sure we will be able to acquire the global modes of the structure up to about 2 kHz of frequency. Now, as you can see, we suspended the gearbox on elastic bunches, basically because we want to make sure that the rigid body modes will be as low in frequency as possible. Theoretically, they should be at 0 Hz, but by putting the structure on soft bungees, we make sure that those modes are low enough and are far enough in particular from the flexible modes of our structure. Now, what we're going to do first, as a first test, is that we want to acquire the rigid body properties of this structure. And to do that, basically, we need to impact at several of the locations where we have the accelerometer. By doing that, we will create an over-determined set of equations from which we can estimate the position of the center of gravity and the moment of inertia of our structure. So now we just finished acquiring all the FRF with the impact hammer. When we load those FRF in the rigid body mode calculator, first of all, we can observe that we get a pretty stable mass line, meaning that our identification will be probably quite successful. We can then estimate and synthesize the rigid body modes and calculate the center of gravity of the structure. The animation of the rigid body properties and the rigid body modes actually confirm us that we did our channel setup correctly, because all the sensors in all directions are moving according to a rigid body mode. That can also be used and can be quite useful to validate if we made correctly our channel setup. So the next step we're going to do after this is we will use a shaker. We will place a shaker on the structure, and then we will acquire FRF in a much wider frequency range to try to identify the flexible mode of the component. Now, Tom is preparing now the support where we can place the shaker, and we will perform 2 excitations in the vertical direction, one here and one basically on the back of the gearbox, and another one in the transverse direction, where we will excite from this side of the structure. So hopefully with the proper excitation and by combining the 3 measurements together, we should be able to correctly identify all the modes up to at least 3 kHz. The modes that we were able to identify actually are very promising. They are indeed what we expected, and the quality of the model that we were able to obtain is indeed very high. So the next step will be the use of modification prediction to try to deduce the effect of the sensor and of the shaker, and then improve the quality of the model again. And once that will be done, with the complete model, including the rigid body properties, we will then use the results from test lab inside Simcenter to perform a correlation and validate the numerical model that we developed for the gearbox. Thanks for watching, and for more information, please visit our website.